Okay, so today I'm going to show you how to solve a polynomial inequality. You need to know how to do that on your progressive test next week. So there are two ways to solving a polynomial inequality. I'm going to show you both ways, and then you just pick your favorite, and that's how you'll solve it on your test next week. The first way to solve a polynomial inequality is algebraically with a number line. The second way to solve it is graphically with a graph. So let's go with the first way. Actually, no matter which way you solve the inequality, here's step one. Step one is that your polynomial needs to be completely factored. So step one. Completely factor. So start with that. So example 1. Let's factor x squared plus 3x minus 10. X plus 5, x minus 2. X plus 1 squared. Okay, so example 1, I completely factored it into x plus 5 times x minus 2 times x plus 1 squared greater than or equal to 0. Okay, let's now do, let's solve it by graphing because I feel like that's what you're going to like best, or it's going to be easiest for you. So let's go ahead and solve this by graphing because that's what we did on our last lesson. We learned how to graph a polynomial. So here's how you solve this by graphing. You need to graph this polynomial that is in factored form. The way you graph the polynomial that is in factored form is with graphing the roots and graphing the end behavior. So let me graph the roots. -5, +2, -1, so I've graphed the roots. The next thing you'll need to graph a polynomial is the end behavior. So remember I showed you on our last lesson, to find the end behavior, we need to find like that leading coefficient. So I need to take the x times an x times an x squared. So if I do x times an x squared, okay, that's a positive x to the 4th. The end behavior for positive leading coefficients that have an even degree is called up, up. So let me draw that end behavior. Up, up. And now, if I had the y-intercept, I would graph it. But I don't have it, and I don't want to find it, so let's just go with this. The way you would graph it is you start on the left side of the graph. So here, start on this positive arrow here. Go towards your root of -5. -5 comes from x plus 5 to the first. When a root is being raised to the first power, it will cross the x-axis straight through like a line. So make this cross straight through like a line. Next, your graph needs to approach the second root of -1. There you go. Now let's look at where -1 came from. It came from x plus 1 squared. When a root is being raised to an even power, it doesn't cross the x-axis. Instead, it bounces off the axis. So right here, just bounce down. Finally, make your graph go towards the next root of x equals 2. X equals 2 comes from x minus 2 to the first power. So that is the degree is 1. So when the root is being raised to the first power, the graph will cross the x-axis straight through like a line. And that's how you graph a polynomial. So that was the last lesson. Make sure you know how to graph a polynomial. That's a separate question on your progressive test worth like 10 points. So make sure you know how to graph it. And now, here's how you solve the inequality graphically. So graphically, you want to know, let me erase this. Okay, you want to know when that polynomial is greater than or equal to 0. So greater than or equal to 0 just means when is the graph at or above the x-axis. So you want to figure out when is this graph at or above the x-axis, because that's what it means to be greater than or equal to 0. If it wanted less than 0, you would look below the x-axis. Okay, but for now I want greater than or equal to 0. So definitely this little area here before -5, your graph is above the x-axis. So that's going to be part of your answer. We're going to write our answer. Let's do it in interval notation because that's what I ask you to do on the progressive test. You should practice set notation, but we're going to go with interval notation for now because that's what you need to do on the test next week. Okay, next, also this little area here, after x equals 2, the graph is also above the x-axis. So that means it is greater than 0. Above the x-axis is greater than 0. Okay, now, but you have to be very careful if you want full credit on the test because I did point one just like this. There's one more area here where your graph is greater than or equal to 0. Specifically, equal to 0. So if you look at your graph, at the root of -1, I know the graph is not above the x-axis, but it is on the x-axis, like equal to it. So that part will be part of your answer. So now let me show you how to write the answer. And that's this is the only, I think this is the only free response that I put on your test, so you can just write your answer. You can just type it up. So here's how we write your answer. My polynomial was greater than or equal to 0 from, let's do interval notation, from -infinity to -5. Put a bracket at -5 because you want to include the -5, since at -5 the graph is equal to 0 because it is on the x-axis. Union. Okay, now at -1 the graph is also greater than or equal to 0, so we want to include -1. And you can just write it like -1 comma to -1 with the brackets to show that it's inclusive. And again, on your progressive test, this is free response, so you're just going to type it up in the box. And finally, the graph was also greater than or equal to 0, which means above the x-axis after 2, so from 2 to infinity. 2 to infinity. On the test, just type in infinity with the parentheses. And that is how you solve a polynomial inequality by graphing. I'm going to pause the video to answer questions, and then I'll show you the other method. Okay, so now you know how to solve a polynomial inequality by graphing. And if you like that method, then just go ahead and use that method. I still need to show you how to solve the inequality graphically on a number line, just because that's what you'll need a lot for pre-cal. So here goes. This is a number line. If you want to solve the inequality using the number line, you first have to completely factor, which we already did. Next, on the number line, you're going to put the roots of your polynomial. So you're still going to graph a -5, +2, and a -1. Okay, so now here's what you do to solve this algebraically. You start by picking an x value that is greater than 2. So start here on the right side of the number line. So let's pretend and we pick x equals 3. So what we'll do is let's plug in x equals 3 into the polynomial to determine if the polynomial is positive or negative at x equals 3. So you go here and you put 3 plus 5. 3 times 3 minus 2 times 3 plus 1 squared. And now you want to multiply that out and see what if the polynomial would be positive or negative. And we don't really care about the actual number. We just care the value of it, positive or negative. So here I have like positive 8 times 1 times 4 squared. Everything seems to be positive. So if x equals 3, then the polynomial will be positive. So you would just put a positive here. And that's going to be true for any number bigger than 2. So if x equals 4, 5, or 2.1, 2.5, anything bigger than 2, if you plug it in for x, it will always give you a positive term. Okay, next, now you need to pick a number between -1 and 2. So here, pick some number. Probably let's just do 0. Seems easy. And it could be any number between -1 and 2. And then you just repeat the process. Take x equals to 0, plug it in your little polynomial, and determine whether that polynomial is positive or negative there. So let's do 0 plus 5 is just 5. 0 minus 2 is -2. 0 plus 1 squared is 1 squared. If I multiply 5 times -2 times 1 squared, that's a negative number. So that means that anywhere from -1 to 2, your polynomial is negative. And now you do it again. This time pick a number between -1 and -5. So you see, like, I think this is much longer. I think it's faster if you just graph it. So on the test, just go by graphing. So let's pick a number between -1 and -5. -2. Okay. So let's plug in x equals -2 into your polynomial. So -2 plus 5 times -2 minus 2 times -2 plus 1 squared. And we want to know whether this will be a positive or a negative term. -2 plus 5 is positive 3 times a -4 times, this is a -1, but it's being squared, so it's going to become a positive. So I have 3 times -4 times 1. That's a negative term. So negative. Yeah, definitely way more work, and there's more chances of you making a mistake. So stick with the graphing. Solve by graphing. And then finally, the last, you do it one last time and pick a number that is to the left of -5. So like x equals -6 or -7 or -1,000 if you feel. I'm going to go with -6. One more time, plug it in the polynomial and determine whether the polynomial will be positive or negative at x equals -6. So I guess I'll squeeze it here. -6 plus 5 times -6 minus 2 times -6 plus 1 squared. -6 plus 5 is a -1. -6 times -6 minus 2 is a -8. And then this is a -5 squared. Okay, and like I just told you, a negative number being squared is just a positive. So I have a positive 25 times a -8 times a -1. That just becomes a positive term. Because negative times negative is positive. Negative squared is positive. So this is a positive situation. So finally, the way you get your answer from the number line is you're still looking at when is the polynomial positive, so greater than 0, or greater than or equal to 0. So same thing. So after x equals 2, you had a positive polynomial. Before x equals -5, the polynomial was also positive. And that's how we got these answers. But then you have to still be careful because it could have also been equal to 0. And that's, remember that at a root, the polynomial is equal to 0. So when x equals -1, this does equal to 0. So that's why you include the -1 to -1. And that's just how you do. Oh, let me write this one in set notation just for practice. But on the test, you need to do interval notation. Let me just remind you of set notation. You would put x is less than -5, or x is equal to -1, or, oh wait, less than or equal to -5. X is equal to -1, and x is greater than or equal to 2. So we'll pause for questions, and then we'll do one other example. Okay, so the second thing that you're learning today, which will also be on your progressive test, and I think it's worth 10 points again, or maybe 5 points because I can't remember, but this is definitely on your progressive test, which is I am going to give you a polynomial graph, and then you have to give me the equation. So I guess it's backwards from what we did last lesson. Last lesson I gave you the equation and you learned how to graph. Today, here's the graph. You need to give me the equation. So again, for sure on your progressive test, somewhere between 5 to 10 points because I can't remember. But here's how you do it. Let's start with number 2. First of all, let me remind you about the root behavior thing. Root behavior. When your root has a exponent of 1, so when root has exponent equal to 1, the graph crosses straight through like a line. The graph crosses straight, and by crosses I mean crosses the x-axis. Straight through like a line. So for example, number 2, notice there's a little root right here at -0.5, 0, and the graph is just crossing straight through like a line. So that means that this root of -1/2, it has an exponent of 1. That's called the root behavior. But I also showed you last time when the root has an exponent, well, first of all, odd exponent, greater than 1, so like 3 or 5 or 7. It needs to be odd, but more than 1, so 3, 5, 7. The graph crosses like a cubic. Crosses like a cubic. So let me show you what that means because it matters. So for example, this root here, 5, 0. Your graph is crossing the x-axis for sure, it's crossing it, but notice how it's not crossing straight through like the line did, it's crossing like a cubic with an inflection point. So that means that this root here of x equals 5 is going to have a degree of like 3 or 5 or 7. And it doesn't matter which one you pick. I always suggest picking the smallest one, 3, because it makes the math easier to solve. So I always suggest just pick 3. So again, that's called the root behavior. Now you got one last option. When the root has an even power. So when the root has even exponent, so it could be like 2, 4, 6, any even number, 2, 4, 6, 8, 10. The graph bounces off the x-axis. Bounces axis. So remember that bouncing means, for example, number 3, notice at the root, -2, 0, the graph doesn't cross the x-axis. Instead, it bounces off the axis. And that's what it means to have an even exponent. So 2, 4, 6, 8, 10. All of them are correct. Again, I would go with the smallest exponent possible. because that makes the math easier. So now that I've reviewed with you the root behavior, let me show you how to do the problem. Example 2. Write an equation in factor form for the polynomial. Okay, specifically, let me just show you how you'll see it on the progressive test. So for example 2, it will already be written in this form for you. Y equals A, you need to solve for A, times, let me start with the first root here. The first root was negative half, so that means that the factor is x plus half. Again, that will already be written for you. And then it's going to be raised to some power b, you're going to have to find that, times the next root is a positive 5, so the factor is x minus 5. And then it's going to be raised to some power c. Okay, so that's exactly how you'll see it on your progressive test. And now I'm going to ask you, what are the values of a, b, and c? So first let me give you 10 seconds to see what you can figure out. You should be able to figure out the possible values of b, c. There's multiple correct answers. By now, I hope you have an answer for at least b and c. So x plus a half to the first, so just put b equals 1. X minus 5 to the third. So the value of b has to be 1 because it's crossing straight through like a line. That's the only correct answer. B equals 1. The value of c could be anything else that's odd, like 3, 5, 7. I suggest you go with the smallest one, 3. So c equals 3. And now it will ask you for the value of a. The way you would find a is by plugging in the y-intercept. So plug in y-intercept to find a. Am I still recording this? Yes, I am. So go ahead and plug in the y-intercept into your equation here to solve for a. So y-intercept, negative 25 equals a times 0 plus a half times 0 minus 5 cubed. Simplify and solve for a. Negative 25 equals 1/2 a times negative 125. I'm just doing some algebra. So if I want to solve for a, just the reciprocal. Over 1. Okay, so that was okay, I'm getting a equals 2/5. Did I do that right? Yes, I did. All right, so I did some math and I worked with some fractions and I got that a was positive 2/5. So I guess final answer, y equals 2/5. So you would type in a equals 2/5 x plus a half x 5 cubed. So this is a question on your progressive test. Let's go with like 10 points because that's worth more. You will have to fill in the blank and tell me a equals 2/5, b equals 1, and c equals 3. I'm pausing the video for questions and then we can do examples 3 and 4. Okay, so then the rest of this was just the same thing. We're just going to keep practicing them. So let's try example 3 now. Example 3. Example 3. So your polynomial will be y equals a, The first root is a negative 2 comma 0, so the factor is x plus 2 raised to some power. And then the other root is 4 comma 0, so x minus 4 raised to some power. Now you need to find the possible values of a, b, and c. So let's start with just the b and the c. X plus 2, the graph is bouncing off the axis, so that means that the exponent here has got to be even. I would suggest you go with the smallest even number, which is 2. So let's go with y equals a, x plus 2 squared times x minus 4. At x equals 4, notice how the graph is crossing the x-axis, but it's not crossing straight through like a line, so the exponent won't be 1. It will be something odd, bigger than 1. I would suggest you go with the smallest odd number bigger than 1, so 3. And finally, you will always be given the y-intercept, so that you can plug in the y-intercept for y and plug in 0 for x and solve for the a value. So let's do it. 512 equals a times 2 squared times negative 4 to the third. Okay, now just simplify, do some math here. 512 equals a 4 negative 64. Sure. And then 512 equals negative 256a. So divide. Negative 2 equals a. So now you have your answer. A equals negative 2, B equals 2, C equals 3. And that is how you do that. I guess we can try it one last time. Example 4. And then I'll just answer any questions. This first root, it looks like a 1 or a negative 1, so put x plus 1. This one, 2, 3, 4, it looks like a positive 4, so put x minus 4. So here, make the b something odd bigger than 1, so make it 3. The c has to be something even because it's bouncing off the axis, so make it 2. And finally, just plug in the y-intercept. Divided by 2 3/8. Make sure you put your answers as reduced fractions on the test, or it's going to mark it wrong. So don't leave it as 6 over 16. Change it to 3 over 8. Okay, so that's today's lesson. So recap. Make sure you know how to solve the make sure you know how to solve a polynomial inequality, either by graphing or by a number line. And then second of all, make sure you know how to write the equation of a polynomial graph. And that's the last thing you'll need for your progressive test. Now go and study.